Good day, Math 107 students. Today we will cover the demo for lesson 4, which is linear and rational equations. So let's take a look at the first rational equation that we would like to solve. If you read number 1, I think you would answer yes to both of those questions, that it's a lot easier to solve a linear equation without fractions than it is to solve equations with fractions. So the goal when we see a rational equation like this is to clear the equation of the fractions. And what makes this a rational equation versus a straight linear equation that has fractions in it is that your variable is located in the denominator. Sometimes it's just one of the denominators. Sometimes your variable exists in all three of the denominators. So let's take a look at this first one. So we have our equation, 7 divided by 2x minus 5 divided by 3x equals 22 over 3. And we would like to know what value of x is going to make the left side equal to the right side. So the first thing we want to do, and this is a new strategy that you need to use when you're working with rational equations, is that we have to remember a denominator can never be equal to 0, since division by 0 is undefined in mathematics. So the first thing you need to do is you need to make sure all of your denominators are in factored form, and in this case our denominators are already factored because the first denominator is 2 times x, so you have two factors, 2 and x. The next denominator is 3 times x, and our third denominator is the constant 3. So we need to make sure that we examine every denominator and identify the value of x that would make that denominator equal to 0. And these are called the restricted values or the excluded values for our variable. So x cannot equal this particular value of values, or these particular values. So in this case, since 2x and 3x, if we set them equal to 0 and we solve for x, both cases give us x equals 0. So the excluded or restricted value for this equation is x cannot be 0. So the next step is we want to think about not having 2x and 3x and 3 in the denominator, but just the number 1, because then it will be a linear equation that we could easily solve. So in order to remove these denominators or create 1 in the denominator, we're going to find the lowest common multiple of these 3 denominators, 2x, 3x, and 3. So one of the visuals you can use to do that is you could factor each denominator, and in this case our denominators come to us already factored. The first denominator is 2 as a prime number, and then x, 2 times x. Both of those factors are already completely factored. They're in factored form, so that's all we have to write. Then we look at the next denominator, which is 3x, and we see that if we were to write 3x, we would borrow the factor of x from the red circle, and then we would times it by 3. And then the third denominator, 3, is already here in the blue circle. So to find the LCM, the lowest common multiple, which most of the time you refer to as the lowest common denominator, and you think of it that way because you're used to adding and subtracting fractions and you need to create common denominators. But remember, in this case, the value that we find, this multiple, is just being used differently. We're multiplying both sides by this multiple. We're not creating common denominators with this multiple. So to find the LCM, you simply multiply straight across and you get 6x. So now that I found 6x is my lowest common multiple of 2x, 3x, and 3, I'm ready to start to solve my equation. Okay, the reason we are doing this, the y, is that we want to create 1s in the denominators so we can easily solve the equation. We're clearing this equation of these fractions. Okay, so let's see what we do. We're going to multiply each and every part of this equation, each term, each part of it, by this LCM, just so that we have exactly the same language. 7 divided by 2x is called the first term. 5 divided by 3x is the second term on the left-hand side of this equation. And this is your constant. That's a term also on your right-hand side. So every one of those black boxes will be multiplied by this multiple 6x. Okay. So let's do that. So I'm going to write each one of them and give myself a little bit of space. I'm just going to make my fraction bar a little bit longer because when I multiply by 6x, I know it's 6x divided by 1, and I don't have to put the 1 in the denominator. So I'm going to multiply that by 6x. And the only reason I can do this is because now I'm going to multiply 5 over 3x by 6x as well. And again, this powerful tool that I have available to me of being able to multiply both sides of an equation by the same non-zero quantity is going to allow me to solve this equation by multiplying both sides by 6x. Okay, so I have multiplied everything on both sides by 6x. That's this step right here. Okay, I've done that. And now it says reduce each one of these terms by dividing out the common factors. Now remember, we can divide out common factors to the numerator and denominator because what that means is you're finding a factor of 1 and you're dividing by 1. So therefore, the value of your fraction doesn't change and you have just reduced it. So let's take a look at how we would reduce this first term here. So we notice that we have a common factor of x divided by x. There's a factor of 1. And we also notice that 2 divides into 6, and that's a 3. And remember, we chose 6 so that it would be a multiple of 2, so that 2 would divide into it. So we've kind of done this purposely. So what do we get here? The x's cancel to 1. 6 divided by 2 becomes a 3. So I'm left simply with the number 21 for my first term. Now let's take a look at my second term. In both the numerator and denominator, I have x. So let's take a look at reducing that by making that a nice big factor of 1. And then I see that 3 goes into 3 once and 3 goes into 6 twice. And now I have 5 times 2, which is 10. So I subtract that from 21. Okay, now finally I have to multiply and reduce the right side here. And I see that the only common factor of 1 is found by dividing 3 by 3 and getting 1, and dividing 6 by 3 and getting 2. And notice on top I have 22 times 2 times x. So that gives me a 44x. Okay, so now this equivalent equation, 21 take away 10 equals 44x, is a lot nicer to solve and easier to solve now that we've employed this strategy. So we combine like terms on the left-hand side by subtracting 10 from 21, and we get 11 equals 44x. And then I divide both sides by 44. So I get a 1 in front of my x. And I get x equals 1/4. So this is my solution. And now I have to make sure I don't forget to check that my solution wasn't one of my restricted values or value. So if I go back to the top, I see, oh, the only thing x could not be was 0. So 1/4 is okay, not a restricted or excluded value. So now I just want to check by going back to my original equation and making sure that 1/4 truly is the solution to this equation. So let's take a look at that. So we have 7 over 2 times my answer, which is 1/4, minus 5 over 3 times my answer, equals 22 over 3. So this is my check. So I have 7 divided by 2/4, which is 7 divided by 1/2, minus 5 divided by 3/4 equals 22/3. So a little work with my fractions. 7 divided by 1/2 gives me 14. How many halves are in 7? Well, there's 2 in every single one, so I've got 7 times 2 or 14. And 5 divided by 3/4 is the same as 5 times the reciprocal, so that's 20/3. And so to do this subtraction, I need to change 14 to thirds because I can only subtract when I have like denominators. So I would have to multiply 1 by 3, and whatever I do to the denominator, I must do to the numerator. So that's 42/3, take away 20/3, and the question is, does that equal 22/3? And we're very happy to see that these are truly equal, so you know you've done your problem right. So your solution to this equation is 1/4. Okay, let's take a look at another rational equation that uses a lot of the same ideas as this one, but our denominators look a little bit different when we start off. Okay, so here we go. We have a rational equation, and it will be very important by the time you finish up this first unit before your first test. You'll be looking at lots of different types of equations. So you should be starting some kind of notebook page where you start to put in different types of equations and write down some ideas for yourself about how you identify that equation. Oh, yes, this has a variable in the denominator, so this is what we call a rational equation. And then jot down some key ideas or actually work through one that you've worked through either in class or in homework so that you have an example with some notes about all the things you need to do to solve rational equations. It's just a little study tip for you. Okay, so notice this equation on the left-hand side has 3 terms, just like the first one did, the first example we looked at. 2 terms on the left-hand side and 1 term on the right. And the first denominator is just little old x, so nothing's happening there. X is sitting there all by itself. But notice the second denominator, x squared minus x, is not in multiplication form. It's not factored. So you have to make sure that all of your denominators are completely factored before you begin. So let's just rewrite this equation so that each of my denominators are in factored form. And the only way to factor this denominator is your friend, the greatest common factor. That's going to be such a critical factoring technique that we tend to forget about, but you should always remember that that is the first question you should always ask yourself when you begin a factoring problem. So now that it's completely factored, we notice that, let me just give you a little bit of language. We say that, for example, 12 is the 4th multiple of 3. Why do we say 12 is the 4th multiple of 3? Because I could take 3 and I could multiply it by 4. So it's the 4th multiple of 3. If I switch that around, I could say 12 is the 3rd multiple of 4. Why? Because I'd have to multiply 4 3 times. So when you look at these two denominators, x and x times x minus 1, can you see that both of these denominators contain a factor of x, but the second denominator is being multiplied by x minus 1. Now, I don't know what x is, but this is already a multiple. X times x minus 1 is a multiple of x. It's the x minus 1 multiple of it. Now, if I had a number here like 3, then x would be 3, and this would be 3 times 2. So it would be the second multiple of 3. If x was 5, then this would be 4 times 5. So it would be the 5th multiple, the 4th multiple of 5. So In this particular case, one of your denominators is already a multiple of the other, so finding the least common multiple is going to be very simple. But before we get there, I'm a little bit ahead of myself. I still have to find the excluded or restricted values. So I have to look at what values will make each of these denominators 0. Well, the first denominator is already set. When you set it equal to 0, that's the value. X is 0. And your second denominator, well, if x is 0, this entire multiplication problem will be 0, or if x is 1. So in this case, we have two restricted or excluded values for this particular rational equation. 0 and 1 are values that would make these denominators 0 and therefore make the whole equation meaningless. All right, so to find the LCM, I'll show you how to do it, but again, I just wanted to point out that x times x minus 1 is already a multiple of x. So the smallest common multiple is that denominator, x times x minus 1. But if you were starting this and you were sort of just, kind of listening to one of your smartphones or, doing something else as you're doing this and you weren't quite paying attention to everything, you might say, okay, let me just go through the steps. So here's my first denominator. Well, how do I make my second denominator? Well, to make my second denominator, I have to borrow that factor of x and then multiply it by x minus 1. So now this borrowed x times x minus 1 gives me my second denominator. X in my first circle gives me my first denominator. And over here on the right-hand side, I have 1. So 1's not going to affect this at all. So to find my LCM, I simply multiply straight across, and there you are, x times the quantity x minus 1. So now I'm going to multiply everything on both sides of my equation. So all I do is I write my first term, and I make my fraction bar just a little bit longer so I can scoot right beside that x times x minus 1. So I've multiplied my first term by x times x minus 1 plus, now here's my second fraction, and I make it a little bit longer, the fraction bar, and I write my original fraction in black, and then right beside it, the 1 in the numerator, I write the LCM x times x minus 1, and then finally, on the right-hand side, I have the number 5, and I scoot right beside that and put x times x minus 1. Now, if you want, you could put that all over 1, which is a denominator, but it's not necessary. Okay, so I am going to divide out the common factors here and reduce each one, and then I'm going to use the distributive property as needed. So the first common factor I see common to the top and bottom is x over x. There's my factor of 1, and I get 1 times x minus 1, which is x minus 1. So this becomes simply x minus 1. My second fraction, notice my entire denominator appears in the numerator, so I'm going to be able to cancel each factor with a common factor in the top, and I will get a 1 in the numerator. And on the right-hand side, I have to use my distributive property to simplify. 5x times x gives me 5x squared, and then 5x minus 1 gives me minus 5x. So this is now the equation that I have to solve. And so let's finish solving this equation. So I drop the parentheses here on the left side. And I see that when I combine these two like terms, I get 0. So I'm just left with x on the left-hand side. And I have 5x squared minus 5x on the right-hand side. And when I subtract x from both sides, I get 0 on this side, and I get 5x squared minus 6x. Now be careful, this is a spot where sometimes students make mistakes. They get minus 4x. So it's negative 5x, take away one more x, or you can think of it as negative 5x plus negative 1x. Okay, to solve this equation, you never want to divide both sides of your equation by a variable, okay? Because you could, without knowing be dividing that by 0 because we don't know what x is. And it also means that you'll lose one of your possible solutions when you do that. So the only way we can begin to solve this problem is to say, is there any way I can make this subtraction problem into a multiplication problem of some sort? And you can see that you have, again, your greatest common friend here is x. So if you pulled an x out front, you would have 5x left because x times 5x gives you 5x squared minus 6. So now you have a multiplication problem equal to 0. So you take each factor and set it equal to 0. And in this case, there's not any work to be done when x is equal to 0. And then here we have a little bit of work to set this equal to 0. So we add 6 to both sides. We get 5x equals 6. And then we divide both sides by 5. And we get x equals 6/5. Okay, so the first thing I want to do is to make sure that neither one of these solutions is part of our restricted values. So I'm going to take a scoot and look back up here. Ooh, and I see 0 is not allowed. So the first thing I want to do is cross off that. This is what we call an extraneous solution. Extraneous. It's a solution to this equation right here, but it's not a solution that will work in our original equation. So now I have 6/5 left as a solution, and I need to check that. Okay, and then you want to make sure you check your solution by plugging 6/5 back into the original equation and seeing if the left side equals the right side. So let's do that. 1 divided by 6/5 plus 1 divided by 6/5 squared minus 6/5. Does that equal 5? Well, let's see. Anytime we have 1 divided by a number, or 1 in the numerator and some number in the denominator, that says take the reciprocal of the denominator. So this first term here, 1 divided by 6/5, becomes 5/6. Now, what does this second term equal? We have 6/5 squared, so that's 36 over 25 minus 6/5, which we will have to change to 25. So I'm going to multiply top and bottom of that by 25. By 5 over 5. And on the right-hand side, we have 5. So let's keep simplifying this here. We have 5/6 for my first term, and we have 1 over 36 25ths, take away 30 25ths is 5 25ths. Excuse me, 6 25ths. Okay, and again, I'm taking the reciprocal of 6 25ths, so that's 25 over 6. So we have 5/6 plus 25 over 6. And the question is, does that equal 5? Well, 5/6 and 25/6 is 36. And you're starting to feel hopeful here because 5 equals 5 and you're a happy camper. Okay. So we have found the solution to this first step, to this second equation here. And we also saw that in this particular problem, we ended up with an extraneous solution. So here's a little thought question for you. What does it mean when you solve an equation and a solution is one of the excluded or restricted values? Well, in this case, we just said it was extraneous. It wasn't a solution to the original equation. However, this question probably should say, what does it mean when you solve an equation and the solution is one of the restricted values, meaning that it's the only solution. I could have written this a little bit better for you. Well, so if we had solved this equation and all we got was this for our answer, if this was our solution, our only solution, then you say there's no value of x that's going to make the left side and right side of whatever equation you were working on equal. So we say there's no solution, or that the set is empty. Remember, this 1/4, this 6/5 here is our solution set. So that number 6/5 is in the set. So we say it's the empty set, and the symbol for this is like a 0 with a slash through it. So this means that there would be no solution to the equation. Okay, so keep that in mind because you might end up having a problem like this in your class activities. Hint, hint. Okay, let me know if you have any questions.